Welcome everyone. In this video we're going to cover problem number 7 on the chaotic review. We want to evaluate the limit as some h goes to 0 of g of 1 plus h minus g of 1 over h. Now actually similar to problem number 6, right, we know that we can actually interpret this as actually some derivative, right? So this will be the derivative of g at 1. Because the definition for the derivative of g at 1, well, let's actually maybe start off at the derivative of g of x. All right, the original limit definition is the limit as h goes to 0 of g of x plus h minus g of x divided by h. So in this case, if we substitute, right, everywhere I see an x, maybe I'm going to plug in a 1. So instead of an x here, plug in a 1. Instead of an x here, plug in a 1. And of course, instead of an x here, plug in a 1. We can see that now g prime of 1 perfectly matches, right, what we're tasked in finding. So we can calculate out g prime of x. So here's our g function. It's going to be 2x. And then input 1. And I'm going to get the value of 2. So we could certainly do it this way. However, right, one of the kind of priority 1 topics for this course is being able to evaluate out limits for the definition of the derivative. And so now that we see that this is the definition of the derivative, we should also practice evaluating out this limit. So let's go ahead and do that as well. So I'm going to do the limit as h goes to 0. And now I need g of 1 plus h. So everywhere I see an x here, I'm going to plug in a 1 plus h. So 1 plus h, quantity squared, minus 1. So that's my g of 1 plus h, minus g of 1. So g of 1, well, when I plug in 1 here, I'm going to get 1 squared minus 1. That's going to be 0. That's pretty nice. All divided by h. And so let's go ahead and evaluate this. The first thing I'd want to do is maybe expand. So 1 plus h quantity squared. So remember, I have to FOIL this out. I'm going to have 1 plus 2h plus h squared. And I know it's kind of tempting. I've seen some people try to just distribute this squared to each piece. And in which case you would get the 1 and you would get the h squared, but you would miss this 2h and you would get the answer wrong. So you really do have to FOIL this all out. Okay, now we subtract away the 1. And we're still dividing it all by h. So we see there's a bit more cancellation here. And now all of the terms remaining, 2h and h squared, have an h in them, right? So we can go ahead and actually cancel out the h on bottom with an h here and an h here, right? Because it's all divided by h. So what's left over? We're going to have the limit as h goes to 0 of 2 plus h. And now we can see there's no problem in just plugging in 0 everywhere I see an h, and I'm going to get the final answer of 2, which of course, right, I was able to also get over here. So we get the answer 2 either way. And the last part of this problem asks us to explain what this quantity represents. And I think there are multiple good explanations for what this quantity represents. So I would like to go over maybe with you on the graph, right, of what we actually found. Remember, this is the derivative. So another way to ask this is, what does the derivative at 1 represent? And so actually, let's go back and look at a picture of the graph. So here is g of x is x squared minus 1. And I've highlighted or kind of, mapped this point 1, comma g of 1, right? And so if I zoom in on this, at 1. Remember, the derivative represents kind of what is the slope of the function at this particular instant, right? How much is it changing at this particular instant? And so if I really zoom in on this, right, we can see around 1, for every step to the right that you take, you go up 2. For every step to the right you take, you go up 2. So again, the derivative, this quantity, represents how the function is changing at this particular instant. And so that would be my answer. Maybe you have your own good answer, but I'm going to say this quantity two represents the rate of change of g of x, or maybe even y equals g of x, at the instant x equals 1. So how much is it changing at that particular instant? Again, one of those key phrases, instantaneous rate of change. Instantaneous rate of change is this derivative. It is this quantity that we calculated out here. And it's even better yet sometimes when we actually have units attributed to this, right? This could be maybe like 2 meters per second, or 2 gallons per minute, or something like this, right? It's an amount of change, a rate of change at a particular instant of time, maybe. All right, that's it for this video. I'll see you guys next time.